Welcome to the DIY Honda Garage channel. The error code P16E8 pertains to a communication error between the Powertrain Control Module and the Shutter Grille System in the Honda CRV models from 2017 to 2022. This communication failure can impede the operation of the grille, which plays a crucial role in managing the vehicle's engine temperature and aerodynamics. Located at the front of the vehicle, the shutter grille is controlled by the Engine Control Unit, ECU. A functional communication pathway is vital for the correct activation and regulation of this system. Diagnostic tools, like the Honda Diagnostic System, HDS, are used to not only detect DTCs, but also to monitor the real-time performance of the vehicle's components. When troubleshooting this issue, it is important to follow manufacturer guidelines closely to ensure accurate diagnosis and effective resolution. DTC P16E8 indicates a LIN local interconnect network communication error between the Shutter Grille System and the Powertrain Control Module, abbreviated as PCM. The shutter grille is responsible for adjusting airflow into the engine compartment, which contributes to optimal engine performance and efficiency. Located directly integrated within the front grille assembly, this system relies on precise communication with the PCM to manipulate the shutter's position based on various driving conditions. A failure in this LIN communication can lead to reduced aerodynamic efficiency and potential overheating issues due to improper airflow regulation. Therefore, understanding the underlying causes of this error code is crucial for maintaining vehicle health. Several factors could trigger the DTC P16E8. Firstly, wiring issues such as shorts or open circuits may disrupt communication between components. Secondly, poor or corroded connectors can impede electrical flow, leading to communication errors. These faulty connections can often be diagnosed by visual inspection or continuity checks. Another potential cause might be a failure within the components themselves, such as the shutter grille actuator or the PCM. Finally, environmental factors can aggravate these issues, such as moisture or abrasions affecting the wiring harness. Identifying these areas will guide the technician towards the root cause of the communication failure. The manifestation of DTC P16E8 can lead to multiple symptoms that affect the vehicle's performance. One prominent symptom is engine overheating, which can occur due to restricted airflow caused by a malfunctioning shutter grille. This inefficiency can also result in poor fuel economy, as the system struggles to maintain optimal temperature ranges. Additional indicators may include the presence of warning lights on the dashboard, specifically the check engine light. Drivers may also experience fluctuating performance during acceleration due to improper engine management. Recognizing these symptoms and their relationship to the DTC P16E8 is essential for timely diagnosis and repair. The first troubleshooting step for addressing the DTC P16E8 is to verify if the error is indeed present. This involves turning the vehicle to the on mode, clearing any existing diagnostic trouble codes, DTC, using the HDS, and then turning the vehicle off. Following a brief pause, the technician must return to the on mode and wait a minimum of 10 seconds before checking for any pending or confirmed DTCs with the HDS again. If DTC P16E8 is indicated, then troubleshooting should continue. If not, there may be an intermittent failure, warranting a check for poor connections or loose terminals at both the shutter grille and the PCM. This protocol ensures a thorough initial assessment of the system's status. In the second step of diagnosis, rechecking the DTCs with the HDS is crucial for identifying any associated error codes. This includes assessing for codes like P16E2, which represents a PGM-FI-LIN communication error for the automatic control generation system. If this code is present, the next steps will diverge towards troubleshooting that specific error. If no related DTCs are present, the process continues further down the diagnostic pathway. This step focuses on systematically narrowing down possible failures within the communication system of the vehicle. Following up on potential error codes, in Step 3, the technician is to conduct additional DTC checks specifically for P16E8, which signifies a LIN communication error with the battery sensor. Checking for this error involves using the HDS to ascertain whether any of these codes have emerged. Depending on the outcome, the technician will follow a specific pathway to either further investigate the components relating to the battery sensor, or move on to examine other error codes such as P16E5, which pertains to communication errors with the DC-DC converter. This targeted approach is fundamental in determining the root cause of the communication issue. In this troubleshooting segment, Step 4 focuses on checking for the P16E5 code. This code indicates a LIN communication error with the PCM DC-DC converter. Just like in previous steps, the mechanic will utilize the HDS to verify the presence of this error code. If the code exists, further detailed procedures will need verification. Conversely, if the P16E5 code does not show up, examination will pivot on the results from prior checks, specifically regarding the operational state of the shutter grille and its connected systems. This precise approach is crucial in isolating areas that may require further scrutiny. Step 5 emphasizes determining the possible failure area by focusing on the shutter grille system and relevant connectivity. The technician starts this phase by disconnecting the shutter grille, upper-lower 4P connector, and measuring the resistance between designated terminals while the vehicle is in the off-lock mode. Specifically, they will measure between test points set out in the process. A resistance reading of 1 megaohm or more is necessary for the system to be deemed functionally sound. If it does not meet this criterion, further investigation into potential shorted wires or other faults must ensue. This step is vital in identifying if the issue lies specifically within the shutter grille or if it extends to other associated components. Upon completing repairs related to the DTC P16E8, it is essential to conduct a final repair verification to ensure that the solutions implemented effectively addressed the problem. This consists of retesting the vehicle using the HDS to check for the reappearance of the original DTC, as well as other error codes. Additionally, drivers should observe any operational differences following the repairs, such as improvements in engine temperature and efficiency. Perfecting the shuttling of air through the grille must be confirmed for proper functionality. The verification process ensures that the repairs meet the expected outcomes and enhances the reliability of the vehicle, ultimately benefiting its long-term performance. To mitigate the risk of encountering DTC P16E8 again, some preventive maintenance practices can be highly beneficial. This includes regularly inspecting wiring associated with the shutter grille and associated components to catch potential wear and tear early. Maintaining clean and secure electrical connectors can significantly decrease the risk of communication issues caused by corrosion or loose fittings. Moreover, performing periodic diagnostics using the HDS can ensure that any emerging issues are detected and addressed promptly before they escalate. By implementing these practices, vehicle efficiency and reliability can be greatly enhanced, promoting a more stable operating environment. In conclusion, effectively addressing DTC P16E8 involves a structured approach where each diagnostic step must be meticulously followed. Understanding the underlying issues that this communication error may stem from, such as faulty wiring or bad connectors, is crucial for accurate assessment and repairs. Ensuring that the Powertrain Control Module can effectively communicate with the shutter grille is key for maintaining optimal engine performance. Furthermore, prioritizing preventive measures not only aids in reducing future occurrences of the error, but also improves the overall reliability of the Honda CRV. Following these guidelines will provide technicians with the tools necessary for successful troubleshooting and repairs. Please like and subscribe to the channel. See you next time.